Assalamu alaikum. This is Muhammad Jahangir Hussain from MJ Mathematics. Today we are going to solve a mechanics paper from Cambridge International AS and A level, May June 23, variant 41. So without any further delay, let's get into the question paper. Okay, guys, this is the mechanics paper from May June 23, variant 41, paper 4 mechanics. Okay, let's get into the question then. Question number one. See, particle of two particles, P and Q, of mass in kg and 0.3 kg respectively, are at rest on the fourth plane. The P is projected at its speed 5 meters per second directly toward Q. After P and Q collide, Q moves with speed 2 meters per second in the same direction as it was originally moving. And in terms of the speed of Q after the collision. Okay, let's see what is happening here. Particle P, particle Q is at rest initially. P is projected towards Q with a speed of meters per second. Q at rest. P, Q, P has a mass of m kg. Q has a mass of 0.3 kg. After the collision, he continues to move in the same direction with a different speed to the second. Obviously, Q must be moving in the same direction. With the speed v meter per second, v is unknown, we'll find out the v. So these are the speed before the impact and the speed after the impact. So if we apply the conservation of linear momentum here, with forward direction, initial direction motion of p is positive. So we have m into 5 plus 0 into m to 2 plus 0.3v, so 0.3v equal to 3m, so v equal to 10m meter per second. That's the speed with which particle Q starts to move immediately after the collision. Now, in the next part, if we, after the collision, Q moves directly towards a third particle R of mass 0.6 kg, which is at rest on the plane. Now, here we have Q, which is here, here, is R, which is at rest. Q moves with speed 10 meter per second. R is at rest. Okay. Now Q is brought to rest. Q is brought to rest in the collision with R. So Q is at rest, and R begins to move with speed 1.5 meters per second. Now, using this function, let's find the value of m. Again, if we apply the conservation of linear momentum here, we have mass of, remember, mass of Q is 0.3 kg, and mass of R is 0.6 kg, 0.3. So 0.3 into 10m plus 0, that's the sum of moment of before collision, equal to 0.3 into 0 plus 0.6 into 1.5. So from this one, we have m equal to 6.3. And third bit. Okay. Now let's move on to the next question. Question number 2. Question number 2, you have a particle P of mass 0.4 kg is projected vertically upward from horizontal ground with 10 meters per second and the greatest height above the ground is by P. So let's show this on a rough diagram. Here we're showing this particle P on the ground with speed 10 meters per second. So what happens to its person? It rises to its greatest height, then returns back to the ground. Yes. Now we have that project. Let's say we have projected it from A and its first point is B, from A to B, and B equal to 0. So if you apply, what are the quantity we know here? We know U, we know V, and we know the acceleration due to gravity. That's minus 10 since it is projected upward. And we have to find S, the distance. So if we apply V square equal to U square plus 2AS, because only this is the equation involving these four parameter U, V, A, and S. So that will give you the answer. U is 10, U is 10, A is minus 10, S is 5. So height raised by particle V is 5. Now, in the second part, when P reaches the ground again, it bounces vertically upward. And at the first instant it hits the ground, P loses 7.2 joule of its energy. Find the time between the first and the second instant at which P hits the ground. Okay? So the first time P hits the ground here, and it hits the ground with 10 meters per second, because initially it was projected with 10 meters per second. So after hitting the ground, it rebounds. And while it rebounds, it loses its 7.2 joule of its energy. So rebounding speed will be obviously less than 10. And after rebounding, it again returns back to the ground again. Okay? So we have to find the time it takes from the first hit to the second. This is the time. That's it. Find the speed, the speed, the speed. Okay? Now we want to find the velocity with which it is bound. Let's call it V1. So A loss, A loss, plus 2. Initial K is half is 0.4, half into 0.4 into E square minus final K is half into 0.4 into V square. We can write it directly half into mass into V square minus V square. And this is equal to 7.23. 7.2 equal to 0.2 times Q square. Q is 10 minus K. So square equal to 36. 10 square minus 36. So V is 8. Now it rebounds to speed 8. And after reaching the highest point, it will return to the ground again and reach the ground with the same speed as the speed with which it rebounds from the ground. So for the second part, if we apply from CDC or CDC, if we apply B equal to U plus AK, in that case B is minus 8, A is plus 8, A is minus 10 into time, the time is 6 seconds. Okay, that's the time between the first and second hit, second time between the instant, first and second instant at which we hit the ground. Okay, that's part B of question number 2. Now let's move on to the next question, question number 3. In question 3, you see a particle moves in a straight line starting from red. That is U0, U0 is 0. Now the displacement is a meter of the particle from a fixed point O on the line is given by this. So 30 is not equal to 0. That is 6. Now you have to find the value of s when the particle is at rest again. Initially it was at rest, equals 0 is 0. Now we have to find the value of t when it is again. For that, since it is to rest, so v is 0, to set v is 0, so we need to find the expression for v, and we have the expression for s. So to find v, you need to differentiate s with respect to t. So we have 5 by 2, which is to the power 3 by 2, minus 15 by 4 times 3 by 2 into 2 to the power 3 by 2 minus 1, that's half. That's it. Okay, now v is equal to 0, so we have 5 by 2, t to the power 3 by 2 minus 45 by 8, t to the power half equal to 0, plus. Okay, 5 by 2, t to the power half common here, we have t minus 9 plus 4. So it cannot be 0. Like initially it was at rest, we need to find next time 9 by equal to 9 by 4. The particle is at rest again and equal to. Now that's the value of g. Now next we have to find the value of s at this instant. So that is 1 by 4 to the power 5 by 2 minus 15 by 4 into 9 by 4 to the power 3 by 2 plus 6. This will give the answer that is 15 by 16 in exact fraction, or if it comes in decibel, that is 0.9375 meters. Okay, that's part question number 3. Now let's move on to the next question. Next question 4. Okay, in question 4, you have the velocity of a particle. Velocity of a particle at time t second after leaving a fixed point O is v meter per second. This diagram shows the velocity time graph. It models the motion of the particle. The particle consists of 5 straight lines. The straight line segments, the particle accelerates to a speed of 0.9 meters per second in a period of 3 seconds. Here, it accelerates to a speed of 0.9 in 3 seconds. Then travels at a constant speed from 3 to 9. It travels at constant speed for 6 seconds. Then comes instantaneously there. 1 second later, it comes instantaneously. The particle then moves back. So velocity is negative here and returns to rest at O. So at the starting point at time 6 seconds. T is unknown here. Okay, find the distance traveled by the particle in the first 10 seconds of its motion. So we see it's the trapezium. This is the trapezium, so distance traveled. Remember, distance traveled in the velocity time graph is the area under the curve. So distance traveled in the first 10 seconds will be the area under the curve in this first 10 seconds, and this first second, the graph is above the time axis, so area is the vision curve and the time axis. And if the trapezium, if you apply the formula of trapezium here, it will be half into A. A and B are parallel sides. A is here, is 10, that's A, and B, this one is 6. So this is 10 plus 6, and 8 is the distance between them. You can apply it directly, or you can find the area using its segment. Triangle, rectangle, and triangle again. Or we can apply it like this. Or half into 3 into 0.9 plus 6 into 0.9 plus 0.1 into 0.9. Either way, the answer will be the same, that is 7.2 meters. Okay, that's 7.2 meters. Now, let's move on to the next part. Then the next part is C. Given that T equals 12, T equals 12, and the minimum velocity of the particle. Minimum velocity is here. Velocity is inverse of velocity. That's minus V, minimum velocity. Now, you have to find this velocity. Now, how do we calculate this one? Remember, particle starts from where at t equal to 0 at O and returns to O at t seconds. Returns to O, returns to there at O at 2 seconds. And then it starts, particle starts from rest at t equal to 0 at 6 Okay, so the distance travel in the first 10 seconds is equal to the distance travel in this second 0 10 to 3 seconds. So this displacement is equal to the negative displacement of the first 10 seconds. The displacement of distance travel in the first 10 seconds is 7.2. The distance travel in the next period of the motion is next part of the motion is minus 7.2. So we can apply the area of this triangle is equal to minus 1.2, and that will be the half into 12 minus 10. That's the width of the triangle into height is minus b equal to minus 7.2. So b is 7.2. So minimum velocity is minus b, that's minus 2. And have to mention the negative sign because this is the minimum velocity. Okay, in the next part, given instead that the speed of the particle, the speed of the particle is t. Here is t, there are some different words for the velocity, greatest speed. And if you look at the diagram, greatest speed is point, greatest speed is 3. If you look at the diagram here, the greatest speed is 9. So the speed point is only possibility that here minus v is 3 here. So if it is 3, then what is the value of t? Again, if it is 3, that's minus 3, then the velocity it is area is equal to 7.2 is into 1, you can calculate the value of t. So half into 3 minus 10 into minus 3 is equal to 7.2. So this will give it 3 equal to 14.8. Okay. Hence, find the average speed of the particle for the whole journey. So, average speed will be total distance traveled. Remember, particle first travels 7.2 meters in the positive direction, then returns 7.2 meters in the negative direction, then travels another same distance in the negative direction. So, total distance is 7.2 times 2. So, average speed will be for the whole journey, total distance 7.2 plus 7.2 is the total time. Total time is 14.8. So, it is 36 by 37 meters per second. On this is the CSF, it is 0.172 meter per second. That's the average speed of a particle for the whole of the motion. And that's part C. That's the discussion. Move on. Next question. Oh, so now, question 5. Say in question 5, four coplanar forces act as a point. Here, the four coplanar. 1, 2, 3, 4. Theta. The forces acting at the point. The magnitude of the forces are S and 50. 40. The direction of the forces are shown in the diagram. Only unknown with F and theta. Given that the forces are in equilibrium, we find the value of F and theta. When the forces are equilibrium, so forces are balanced. So in two-dimensional, we first need to consider two directions. So let's say dotted line is x-axis and perpendicular to this is the this. And here you see 10 Newton and 50 Newton. These two act directly along the axis. And the other two forces, F Newton and 40 Newton, does not act along the axis, so you need to resolve it. F Newton makes an angle of theta with the x-axis, so x component is F cos theta and y component is F sin. And for 40 Newton angle with x-axis, negative x-axis is 60 degrees, so its component is 30 cos 60 degrees, and it lies in the second quadrant. In the second quadrant, x negative, y positive. So x component in the negative direction, y component in the positive direction. So the side 60 factor y component of 40 Newton. Now the forces are in equilibrium, so are balanced. So first let's resolve. So it's vertically upward force, F sine theta plus 40 sine 60 equal to 50. So we have F sine theta 50 minus 20 root 6. So that is F sine theta. Let's say it is equation 1. And then if we resolve horizontally, we have 10 plus F cos theta. So it is cos 6. We resolve horizontally. Sum of component in the positive direction as F cos theta plus 10 equal to 40 times 60. So F cos 40 cos 60, my bad, not tan 60. See in the diagram 40 cos 60. So F cos theta equal to 40 cos 60, that's 20 times 10. That's equation 2. Now we have two equations. Two unknowns solve it. So instead, one of the unknown is theta, the other one F. So why don't we divide sin theta by cos theta? That is equation 1 divided by equation 2 will give you F sin theta by F cos theta on the left hand side. On the right hand side, we have 60 minus 20 root 3 by 10. That is tan theta is equal to 5 minus 2 root 3. Okay, 5 minus 2 root 3, then tan inverse of this theta is equal to theta corresponds to one decimal place, it is 18.3. Remember, otherwise theta, there is a degree sign on theta, so theta is a numerical value, so it's 18.3. In fact, it counts as 18.3 to 18.3 to 7 plus 1 plus, so if it is correct to one decimal place, then it is measured in degrees, so theta is 18.3. Now, if you substitute the value of theta, remember why we are substituting the value of theta in one of the equations to find the value of f, we need to substitute a more accurate value of theta. So we have to use more decimal places, 18.327. So that will give you theta is not 7, f is equal to 7, okay. So one. Okay, from here, tan theta equal to, so we have to again. So we have tan theta equal to 5 minus 2 root 3. So theta is tan inverse 5 minus 2 root 3, which is we are finding the angle in 3, so it is 56.9224. So that's if we look at to one decimal places that is measured in degree, so theta will be 6.9. Then substitute the value of theta in one of the equations, we get the value of f. So f is 10 by cos theta. And while we are calculating a using the value of theta, we need to use more accurate value of this theta so that it can use more decimal places. So the answer here is not accurate. And in that case, f will be 18.2. Okay, correct. So use it. So these are the value of a and theta. That's for a. Now let's move on to the next part. The next part is given instead that f is 10 root 2 and theta is 45. Find the direction and the exact magnitude of the resultant force. To find the direction and exact magnitude of resultant force, since we know this is not in equilibrium because the value of f has changes and the value of theta is different. So why don't you find the resultant as the sum of all the components? So we have 10, 0, 10 Newton x and thing along the x-axis, so its component is 10 and y component is 0. And then we have f acting at an angle 35 degree with x-axis in the first quadrant. So x component is positive, y component positive as well. So 10 root 2 cos 45, x component positive, then root 2 sin 45, y component positive, plus the component of 40 Newton, and the negative base to minus 40 cos 60, plus 30 x, it is in the third quadrant, so x component minus 40 cos 60, y component 40 sin 60, plus the 50 Newton in the negative direction, so x component is 0, y component is minus 0, and so resultant has x component equal to 10 cos 10 to 2 cos 45 minus 40 cos 60 cos 0, and y component 0 plus 10 to 2 sin 45 cos 40 sin 60 and 50. So we have x component equal to 10 plus 10 minus 20 minus 20, 0. X component is 0 and y component 10, 10 20 root 3 minus 20 root 3 minus 40. So this is 40 minus 40 plus 20 root 3, that's negative. So magnitude is 40 minus 20 root 3 along negative along the direction, vertically downward along the direction of 50 Newton force, or direction is downward. Okay, that's the magnitude of the resultant and the direction. Yeah, x component of the resultant is 0, that's why the resultant acts vertically, and the y component of the resultant is negative, so it acts vertically downward, that is along the direction of the 50 Newton force. 50 Newton force was vertically downward, the resultant is also negative. And magnitude of the resultant is 30 minus 20 root 3. Okay, that's for the so the bit next we have question number 6 here. In question 6, the two particles P and Q of mass Q of mass quantity Q are of 0.1 kg respectively are attached to the end. The light inextensively string. The string passes over a fifth fourth pulley at B, which is attached to the inclined plane. This pulley is the fourth pulley. Particle P lies on its fourth plane. This plane is smooth and inclined at 60 degrees. Particle Q lies on the plane B, which is inclined at theta. The horizontal, whether it is smooth or rough, it is not continuous. The string is third, the particles can move on the lines of vertex flow of the two planes. Okay, it is given that theta equal to 60, the plane BC is rough. Okay, is 60, and when this is rough, coefficient of friction between Q and the plane BC is 0.7. Particles are released from where determine whether the particle moves or not. Let's see whether particle moves. If theta is 60 degrees, then what happens? If there is both surfaces, if you consider both surfaces to be smooth, in that case, which one will descend to determine when which particle descend on the ascent is determined by the weight or component of wave along the direction of motion. Both particle can move along the plane. So along the plane, component of weight of P is 0.2 into 10 into times 60. So 2 times 60 for P, and component of weight for Q is 1 times theta. Theta is 60. So that both have 10 angles. So 2 times 60 is 4. So P is about to move if both plane is moved. But the thing is, when BC is rough, so there is extra friction. Now, we have to determine whether 2 sine 60 is more than friction and 1 sine theta. If 2 sine 60 is more than friction and 1 sine theta, then particle P moves. Otherwise, the system cannot move. Okay? So, first for Q, for the question on Q, you have convolution here. Component of weight 1 sine cos 60 for Q along the normal direction of the normal to the plane are equal to 1 cos 60. Friction, maximum friction, A with most, friction is maximum and maximum friction is mu1. 0.7 into 1 cos 60 or 0.7 cos 60. Now we have to check whether 2 times 60, which is 3, and 1 times 60 plus 0.7 cos 60. If you compare these two, which one is better? This is 3 by 2 plus 0.35. Okay? So let's calculate it into decimal. Is 1.216. And this is 3 is 1.7205. So, particle, oh, okay, particle P contains 2 times 60 greater than friction plus 1 times 60. So, P moves down the plane. Okay, Q moves up the plane. Okay, that's part A. Now let's move on to the next part. In the next part, it is given instead that the plane BC is smooth. Okay. The particles are released from rest, and in the subsequent motion, the tension in the spring is 3 minus 1. The magnitude of acceleration of P, find the magnitude of the acceleration of P as it moves on the plane, and find the value of theta. Okay, if the particle both plane are smooth, then for P is what we have. For P is C, component of weight minus tension. Okay, equal to then A. And for Q, tension minus weight, density is 4 times no friction, tension minus component of weight equal to Mn. For the P first, for P, if we apply 2 times 60 minus T equal to Mn on 2A. T is here, 3 minus 1 on 2A. So A is 1 by 0.2, that's 5 meter per second square. Now, use this A for Q. For Q, we have P minus 1 on theta, which is 0.1 into A, 3 minus 1 sin theta, 0.1 into 5 sin theta equal to root 3 minus 1.5, which is equal to sin inverse root over 3. So that is 13.4, which is equal to 1 decimal, right? Okay, that's it. So that's the part B. For the part on this question. Now let's move on to the next. The next question is a car of mass 1200 kg is traveling along a straight horizontal road. So straight horizontal road. The power of the engine of the car is constant and is equal to 16 kilowatt. There is a constant resistance to the motion of the car is 500 newton, and the acceleration of the car when the speed is 20 meter per second. Now, while it is moving along a straight horizontal road, what are the forces on it along the direction of motion? The driving force provided by the engine of the car, and there is resistance, so there is acceleration, and driving force is equal to power provided by the engine of the car, thereby is speed. Now, if we apply Newton's second law here, it's equal to ms, so d minus r equal to m a d is power 16,000 by v 20 minus r, which is 500, or 1200. So A is 0.35 meter per second. Okay, that's part A. Now let's move on to the part B. Part B is meaning that the power and resistance forces remain unchanged and the steady state at which the car can travel. At steady state, acceleration is zero. So in that case, G equal to R. While moving in the horizontal road, G is P by V. P is 16,000. P by V equal to R. So G equal to P by R. V 16,000. R is 100. So that is 32 meters per second. And the speed, steady speed at which the car can travel along the straight horizontal road. Okay, that's part B. Now let's move on to the next part C. Here you see the car comes to the bottom of a straight hill length 316 meter, inclined at an angle to the horizontal of sin inverse 1 by 60. Okay, so if the angle is alpha, then sin alpha is 1 by 60. Power remains constant at 16 kilowatt, but the magnitude of resistance force is no longer constant and changes such that work against resistance force ascending the hill is 128,400. The time taken to ascend the hill is 15 seconds. The distance is 316. Given that the car is traveling at a speed 20 meters per second at the bottom of the hill, find its speed at the top of the hill. So, while let's see what is happening here on the rough diagram. It is moving at the speed of 20 here. Now, it wants a distance of how much? 316 meters. And we have to find the speed at the top of the hill. Now, will this speed be more than 20 or not? We don't know. So you have to assume either it is more than 20 or less than 20. If you assume that he is more than 20, then there is a gain in case. If you assume that he is less than 20, then there is a loss in case. In either way, whatever assumption you make, the answer will be correct. Because if you assume it is gain in K, then we will use half in V square minus V square. But if V is less than 10K, then obviously it will be negative gain. Negative gain means loss. Now, automatically it will be correct. So we don't need to worry about that if consider one of them. Okay. Now, what is the work done since it is not constant, so driving force will not remain constant. So what will be the work done by the engine of the car? So that is the external work done. Work done by the external force will be since you know the time it takes to travel this distance. So power into time will give you the work done by the engine of the car. Power is 16,000 times 15 for 240,000 joules. That's the work done by the engine of the car. Now, there is GP gain. GP gain is also how much? Since it is moving along an inclined plane, so mg sine alpha into the distance along the plane. Okay? mg, mass of the car is 1200, so mg is 12,000. The sine alpha is 1/60 into s is 216. And that is 62, 62,200. And work against resistance is 128,400. Okay. So if you consider there is K gain, let's consider that there is K gain. Okay. Although the actual thing might be K loss. So if you consider K gain, it will be half into 1200 less into V square minus C square to think square. So that's equal. Now, if you consider the work energy principle, we know work by external force plus loss equal to gain plus work against force. Now, work by external force, that's the work done by the engine of the car, will be 240,000, and there is no loss, so it's zero. There is gain in GP 63,200. The same increase 600 into V square by T square plus there is work against resistance 128,400. So from this one, calculate B and we'll find that B is 21.9 meter per second. Although see here we have gain in V. So our assumption was correct. Anyway, if I start with loss in K, then we'll have 27 is this guy, and use log. You have to put the log on the left hand side of the equation. Then we calculate, you get the same value of. You can check it out yourself. Okay, that's it. That part C is okay. Is there any more part? Okay, that's the end of this question, guys. I hope it is clear to you. If you have any query, any question regarding any part of the question paper, you can inform me in the comment section. I think, uh, I'll try to give you a better answer to your query. Okay, that's it. That's it for today. In this video, see you in the next video. Until then, Allah Hafiz. Assalamu alaikum. Walaikum. The one thing is, if you think this video is helpful to you, don't forget to put the like, subscribe to the channel to get the new videos every week. Okay, so see you in the next video. Until then, Allah Hafiz. Assalamu alaikum. Yeah.